Okay, in this video, I show you how to do an assignment problem. And an assignment problem is one of these interesting optimization problems where the decision variable is a binary variable. It's a 0 or 1, but it's a naturally occurring binary variable. So you don't have to force it to be a binary or an integer for it to work. Uh, it's hard to know when that's naturally occurring integer is going to occur. Um, I don't often know, so usually what I wind up doing is solving the problem without requiring my variables to be integers, and if it doesn't do what I want it to do, then I force them. But it's a real straightforward problem. Is that we've got 5 people and we got to assign them to these 5 jobs, and only one person can work a job. So I could assign Al to any of these. I could assign Bill, but I could only assign exactly one to Al, exactly one to Bill, and I'm going to make sure all of the jobs have someone assigned to them. So if you start with this data structure, and this is the cost, and so your job is to assign that's the least amount of cost. So you can see Al looks like that his best one is job 4, and that's his cheapest, and also job 4, it looks like he's the cheapest one, so maybe it makes sense to do Al to job 4 and just keep working your way through that. But with all the different combinations, there's a way to use optimization, so let's do that. First thing I'm going to do, I'm going to copy the entire data structure and go down, and then all of these I'm going to make into just a number, and I'm going to put a 0 in there. And I don't really need decimal places. Actually, let me show one. So these will represent, did I assign the job? So if that's 1, that means Al's assigned to job 1. 0 means they're not assigned. So we have to make sure that the sum of all of these, every one of those has to be less than or equal to 1. You can't assign them to more than 1. And also we need to have the sum of all the jobs, and these have to be exactly equal to 1. So these need to be less than or equal to 1, which means that you don't have to assign Al to work, but you can't assign him to more than one thing now. And these all have to be equal to 1. All the jobs have to be assigned. Oops. Okay. Once we have these, now let's set up our cost function. Which are the cost against the assignments. So now when I bring up solver, what I'm trying to do is take this cost function and minimize it by changing these cells. So these 25 cells I want to change, and then I need to add some constraints where these all have to be less than or equal to 1, and these have to be exactly equal to 1. You got to assign the job, so it can't be less than or equal to. So we've got these two, that, use the simplex algorithm, and solve it. And this pops up, and you can see that it assigned Al to job 5, not job 4. And job 3 was assigned to Bill. You can also take this. I'm going to format this cell. And I'm going to do a conditional formatting. Sorry. I'm going to do a conditional formatting of this cell. I'm going to say if that cell value is equal to 0, I'm going to have it disappear. I'm going to make the font color be that. And I'm going to copy that and paste this format, paste special the format. So it's a little easier to see. So you can see that Al, I mean, there's a number there, but it's formatted to be to be white because it's 0. So Al went to job 5, Bill does job 3, Cindy does job 1, David does 4, and Earl does 2. So that will give me my lowest cost of my assignment. And you notice all these are zeros and ones, and I did not force it to be. When I was in Solver, I did not force, I didn't have to add a constraint to force all these to be binary. And you could restrict things if you wanted to say, okay, I want this to be exactly 1. I want to assign Al to this one. If I want that to happen, and then I add a constraint and say this value must be equal to 1 and resolve it, you now see Al's assigned to 1, but it cost me. It cost me $2 more. So that's not the assignment you want. You want to go back to Solver. When you force something to happen, if I get rid of that and then solve it, you can see I get a better answer. Okay, so that's an example of an assignment problem. It's naturally occurring binary variables. There's rules on how that happens, but like I said, generally what I do is I solve it, and if they all be natural, if they're all integers without me trying to, I'd say that's awesome. Otherwise, I have to add the restrictions of making those integers or binaries. Thanks.